Question 7, that is your global boundaries question. First thing, it gives you information that you will need to refer to later on. Gives you information about different global processes. What it affects, what unit of measurements, the actual boundary, number boundary, the pre-industrial and the recent data number. So this data is here for a reason, but it doesn't refer to it right away. So you've got a table with a lot of data. Your first question, it's a definition question. Define the term planetary boundary. It's a safe operating space, and if you cross the threshold, you have got an exponential change, an irreversible change, something that gets you from that safe operating space, where those global processes are actually all operating in, hopefully. And once you've crossed that threshold, that's when you've got the problem. The definition here on the mark scheme, a threshold value for global processes that is affected by human activity. And crossing the boundaries can generate an abrupt or irreversible environmental change. Okay, the safe operating space would have been perfectly fine there. So for humans to have that safe operating space would be there. Then this second question, it's again a definition for starters, the term biodiversity. Thank you for giving me the number of different species available, but you need to have the number of different species within an area to get you to have that mark. So biodiversity is the description for a number of species in a particular area. The second mark, any action to delay the biodiversity loss. And the list is long: seed banks, captive breeding, fishing, quotas, trade agreements. What is it? There's a whole list there. Trade restrictions, management of wild population, habitat destruction, reduction, and so on. So it's a whole list, and you did pretty well on that second part here. So that was relatively easy in the bigger scheme of things. This one here, I'm calling it look at the monkey question, because it gives you something fantastic and everyone is looking at something that's absolutely fantastic, and then your question actually asks you something else. It's in my head, I'm calling this look at the monkey, or like the Duracell bunny. You've got the Duracell bunny clapping away and you're all looking at that, and actually afterwards the question asks you something else. It does give you a great deal of information, beautiful information, all about carbon dioxide levels and that little spike at the end of carbon dioxide levels, and your eyes are all drawn onto this here. That's the look at the monkey part. And then comes the question. Read the question with me and read the question slowly. Analyze the data given in the table. This here is a graph, it's not a table. Okay, the data in the table. Analyze the data in the table. Look, here is the table. Analyze the data in the table and draw alternative. So not this here above, okay? Don't do this here, because it's an alternative and a different conclusion as to the possible causes of the increasing extinction rate. So we've got an increasing extinction rate. Where in the table can we see an increasing or something that has recently potentially led to increases in extinction? We have to look somewhere here. So the value from pre-industrial to recent, because that would kind of explain, if there was a change, a drastic change here, that would explain the increasing extinction rate. Explain how you reached these conclusions. So let's actually look at the table. Let's analyze the table. Where do we have something that really sticks out like a sore thumb? Here, we've got the biodiversity loss, okay? We have seen the biodiversity loss is drastic. The change is up to times 1,000. So it's a drastic change there. Now the question is, where does that come from? Can it potentially come from climate change? Have a look at the change from just underneath the boundary to just above the boundary. The percentage increase here, not quite drastic, something like maybe a 50, 60, 70% percentage increase. Here, that's a bit more than double. So 120% percentage increase sort of thing. What happens here? Does that double? Hold on a second. We will get from 400 to about 800. Hold on a second. We're getting from 400 to about 2,000. That seems to be quite a big change. Quite a big change. So there is a change here. There is a change here. But the most drastic change here happens in the freshwater use boundary. So, what could happen? Freshwater use. We need fresh water for drinking. Where does it come from? All of rivers, lakes, streams, marshlands, we're draining them. So, it's a redirection of water. You can also argue that a different land use and therefore the drainage of soil, as to do with agricultural practices, for example, has a huge impact on biodiversity loss. Okay, let's look at the mark scheme. I just wanted you to clearly see if it says look at the table, then look at the table, and it's the look at the monkey question. So here we go. The increasing demand for fresh water, land for crops, as a possible cause of an increase in extinction rate. So why? Because you have got a huge increase, a significant increase. For me, you wouldn't have needed to quote the numbers in particular, but obviously it's an extra mark that you can get if you've got a harsh examiner. You might actually have to. So the pre-industrial value is relatively low. The post-industrial value, the recent value, is a whole lot higher, significantly higher. You can obviously argue that the use of the land use for crops is an effect on freshwater use as well, and that leads to destruction of habitats as well. So linking it to that as land use, and yes, there is an increase. It is over doubled. It's just here that we have got a significant increase here. Okay, that was question 7.